Hi, hello, vanakkam, and welcome back to yet another episode on your favorite Little Law YouTube channel. And I welcome you all to the fourth episode of Locust. So we're going to understand the threads and architecture. So I welcome you all back to our interesting session on Locust. So today I'm going to answer the question where everyone asked me like how does Locust simulate thousands of users on just one machine? And just imagine we have got a lot of challenges when we wanted to run a load test in JMeter with more than 1,000 users, but more than 200 to 300, a system will automatically get shut down, or sometimes the services will get stopped, right? So but Locust handle it like a breeze. So we are going to dive into the green threads, the G event, and the architecture that makes Locust instantly insanely efficient. And let's go. So the first thing is the $1 million question. Yes, the million users. Yeah, that's what we're going to see today. So the question is, how can Locust run thousands of concurrent users on a single laptop? And the answer is all about architecture. The way it was architected is will answer you how we can run more than 1,000 users on a single laptop. So now we'll see the answer for this. So the first thing is the traditional tools like JMeter use operating systems, which we call it as threads, right? And each simulated users equals one OS thread, which is one operating system thread. And the threads are expensive. So each one uses 1 to 8 MB of memory, 8 megabytes of memory. So just do a math. 1,000 users equals 10 gig of RAM, and that's why traditional tools max out so quickly. And now coming to Locust, completely it's a different story. Locust uses green threads through a library called G event. Each green thread uses only 4 kilobytes. Just imagine the difference between 8 MB to 4 KB, right? So 10,000 users, it's going to consume only 40 megabytes, and that's 1,000 times more efficient when compared to JMeter. And this is why Locust scales so dramatically on the same hardware. And I am happy that I have answered a lot of your question. And now moving on to the next slide, the restaurant analogy. So the traditional threading is like a restaurant where every customer gets their own dedicated waiter. So 100 customers means you need 100 waiters, and that's expensive and chaotic. And now for Locust, it's very different, because imagine you have just five smart waiters, and they're going to serve 100 customers. So when a customer orders food and has to wait for the kitchen, the waiter does not stand there. He or they immediately help another customer. So when the food is ready, they deliver it and they move on. And this is called cooperative multitasking, and that's the secret for Locust efficiency. And that's why you're able to achieve more than 1,000 users in just one single laptop. And then next part, which is the technicality of the same thing. So when a simulated user make an HTTP request, the G event doesn't wait. So the green LED immediately yields control back to the event loop. So the event loop then switches to another green LED, which sends its own request and yields, and this happens thousands of times per second. Just imagine, thousands of times per second. So when a response arrives from the server, the event loop notices and switches back to the waiting green LED. It processes the response and it wait a bit and then repeat again. So the key insight that we have to know here is most load testing is just waiting for server responses, and G event ensures your CPU never ever sits idle during that waiting time. Brilliant, right? Coming back to the next slide, the single machine. So single machine is equal to three components. And now let's look at what actually runs on your machine when you start Locust. So the first thing is your component, the first component, the web server on port 8089, and this serves the UI you see in your browser, the user interface that you see in your browser. And next, the component 2, the second component, which is the master process. Even on a single machine, Locust uses a master. It coordinates the test and it collects all the statistics, each and every single data from your machine. And then the third component, which is the worker processes. So by default, Locust creates one worker per CPU core, and each worker spawns greenlets and execute your test. So if in an interview they ask you what are the three components, you have to tell them that it is going to be the web server, and then the master process, and then the worker process. So if you are able to answer this question, then you are really good. And then moving on to the next slide, which is why workers, what the workers are doing. So you might be wondering why multiple workers on a single machine and what are they doing there, right? So Python has something called the global interpreter lock, or GIL we call it as. So the GIL means only one thread can execute Python code at a time, even on a multi-core processor. But the trick here is GIL is per process, not per machine. So by using multiple worker processors, Locust bypasses the GIL, that is global interpreter lock. The next part is 8 CPU cores means 8 workers, which means each running on its own core. This is how Locust uses all your CPU power. And this might be looking something different when compared to JMeter, but this is how it works. That's the power of Python, and that's the power of Locust. It actually helps you to run your tests. So again, I told you the way that the global interpreter lock works. So which means only one thread can execute Python code at a time, even on a multi-core processor, and you have 8 cores, which means you have 8 workers to work for you. So the last one, which is the takeaway. So before we complete, a quick takeaway on this. So green threads are 1000 times more efficient than OS threads, and this is the reason the Locust is able to scale to whatever limit that we need to achieve. The next thing is the G event handles all the cooperative multitasking automatically. You don't write special code, it automatically works. The next thing is even a single machine uses the master worker model, and this architecture scales naturally. And just remember, if you want to emulate the same item in JMeter, you want to have at least two machines, right? The master and slave, and you have to establish the RMI, you have to establish various protocols and lots of other stuff that are behind it. But just imagine Locust does it very simple in the same machine in just one single laptop using GLI, and that's a part of Python Locust again. And then multiple workers let Locust bypass Python's GIL and use all your CPU cores. So in the next episode, I'll take you through the architecture and scaling it across multiple machines to generate massive load. So don't miss it. The next session is going to be more interesting and informative. And I just understand that okay, you must have by this time you must have installed the Locust, and I also understand that by this time you must have created your first test. In case if you have any blockers or if you have any issues, please reach out to me in the WhatsApp or in the YouTube comments. Thank you so much, and see you all in the next video. Until then, it's bye bye, Francis Shanmugam and your little Sla. Take care and bye bye.